Additive manufacturing, the idea that changed an industry, building things layer by layer, bringing innovations to the world never dreamed possible. Building designs, building parts, building an industry. We give you strength in numbers. Together with partners, members, industry, academia, and more, SME is building a home and a community of over 200,000 professionals. People like you who are advancing 3D technologies and creating incredible innovations. You have questions, we have answers. No matter where you are on your journey in additive manufacturing, exploring possibilities, designing new innovations, or facing the challenges of scaling up production, SME is your resource every step of the way. SME is fully committed to the advancement and increased adoption of additive manufacturing technology. That's why we bring the industry together, making connections face-to-face at North America's leading additive manufacturing event series, RAPID plus TCT. Together, we build relationships. SME's Additive Manufacturing Community provides you with unlimited access to industry experts, connecting you to world-class knowledge that's advancing the manufacturing industry. Technical groups working together to create content and programs, accelerate industry standards, and solve challenges. We build knowledge. SME is your 3D technology resource. Technical papers, conference presentations, industry news, videos, and webinars keep you on the leading edge of development and prepare you for what's next in the amazing world of additive manufacturing. Together, we build the future. Attracting students to exciting careers in manufacturing through contests, competitions, and dynamic hands-on experiences. We build reputations with certifications, establishing the gold standard for knowledge and preparing you for unlimited success. SME leads by partnering with the R&D community, universities, national labs, and America Makes to drive technology development. Together, we're building a skilled manufacturing workforce, connecting skills with jobs, while integrating new technologies and create products that couldn't be created before. We've come a long way, and so much more is possible. Together, we'll forge new frontiers for the unlimited, powerful future of additive manufacturing for generations to come. SME is building the ultimate powerhouse community in additive manufacturing. We're better together. Welcome to SME. Welcome home.
Ladies and gentlemen, please welcome to the stage Executive Director and CEO, SME, producers of RAPID plus TCT, Jeff Krause.
Good afternoon. Did you like that video? Welcome to the RAPID plus TCT 2018 Kickoff. Wow. Can you believe it? This is our 28th year of RAPID plus TCT. 28 years. And we have taken over every inch of the Fort Worth Convention Center. As the producer of RAPID plus TCT, SME's goal is to advance additive manufacturing technology and increase its adoption within the industry. We work to attract future generations to manufacturing professions and to develop the current and the future workforce. As manufacturing has evolved, so has SME. We were among the first to embrace the potential of additive manufacturing. More than 25 years ago, SME's rich history of supporting manufacturing led the pioneers and innovators of 3D technologies to make SME the home for their new rapid prototyping technical group. Today, SME connects hundreds of thousands of people in additive manufacturing, continuing the original vision of and commitment to creating an extensive community. We are your definitive industry resource for knowledge, experience, education, and connections. SME's RAPID plus TCT event plays a vital role in defining the future of additive manufacturing and convenes the most experienced and influential community in the industry. RAPID plus TCT is the leading event in North America for discovery, innovation, and networking in additive manufacturing. We are very thrilled that you are here, and we look forward to a week of connections, learning, and inspiration. From outer space to medical to Hollywood, 3D printing has become increasingly capable and accessible on a global scale, and manufacturers continue to innovate across a diverse range of industries. As an example, I'll call your attention to our stage set right here. Titan Robotics and Macy Consulting work together to 3D print the RAPID plus TCT podium and the hexagons behind me. Please join me in thanking both organizations for providing such innovative additions to our presentation stage. SME's community of additive manufacturing experts include many influential people who contribute their time and their expertise to building the RAPID plus TCT program. This is a program by industry, for industry, and these individuals spend countless hours to bring you a definitive and innovative program. Now, I'd like to invite all the RAPID plus TCT 2018 conference advisors and medical manufacturing innovations advisors to please stand and be recognized for your selfless dedication to the advancement of additive technology. Please note their names on the screen and see the details in the event guide. Thank you. Now, this is an interactive session. No standing idly by, so you're invited to get involved right now. So we've added a very innovative audience participation technology called Slido. Slido will assist you to ask questions, to provide feedback, and share your opinions with all the folks here at RAPID plus TCT. There are two ways to be a part of our live polling and Q&A sessions throughout the week. The first way is for you to download, if you haven't already downloaded, the RAPID plus TCT app. Once you download it and you're inside that app, simply press on the Slido tab and enter the following code, RAPID event, all one word, RAPID event. The second way is you can go to slido.com from any device and enter that same code, RAPID event. Slido is very easy to use, so let's prove that to us right now. So get your phones ready. Let's take our first poll. Pull your phones out and be ready to be heard. The first question is, how many years have you attended RAPID plus TCT? So we're going to ask you to count. The first answer, possible answer is, this is my first year. Or is it 2 to 5 years? Is it 6 to 10, 11 to 15, 16 to 20? Or have you been here forever? Let's see what it has to say. It's looking like first year, 62%. 24% have been 2 to 5 years, and so on. Now, this poll is open. It will be open for a little while, as when we do all the polls. So if you haven't yet had a chance to submit your response, please do, and we'll be back and show you some more. We're very excited to be here today to recognize SME's Additive Manufacturing Community advisors and outstanding award winners. Today, we are recognizing rising stars as well as internationally recognized professionals who are moving the additive manufacturing industry forward. Would you please now join me in welcoming Jeff DeGrange, Chief Commercial Officer, Impossible Objects, LLC, who is the current chair of SME's Additive Manufacturing Technical Community, and Jeff will announce our award winners. Jeff, come on up.
Thanks again, Jeff, and hello, everybody. I'm excited to be here this afternoon, not only to be part of the RAPID TCT event, but also the opportunity to recognize our current community advisors and our very deserving award winners. Before we announce this year's awards, I'd like to take a few minutes to recognize our current additive manufacturing community advisors who are with us today. As you can see displayed in the screen behind me, this group has over 100 years of combined experience in 3D printing with backgrounds in medical, aerospace, automotive, academia, spanning materials and techniques from plastics to metals and even hybrid technologies. Would you please stand to be recognized, advisors? Thank you all for your time, energy, dedication to SME's additive manufacturing community and making it so successful. So now I'd like to welcome Carl Decker to the stage. Carl is the president of Metal Flow and the chair of SME's Direct Digital Manufacturing Group. He'll be introducing the judges for our Direct Digital Manufacturing Challenge, as well as announcing this year's winners. Carl.
Okay, since 2008, the SME's Direct Digital Manufacturing Tech Group has held an annual competition, student competition for high schools and college students. Allows them to showcase their technology and commercial talents using additive manufacturing to add value to a particular design. Over the years, the students have submitted some incredibly inventive designs for things like inspector drones for underneath bridges, door handles, golf clubs, golf club handles and irons, crutch hand grips, a camera cap, knee braces, as well as a 9-piece car body, and even a prosthetic leg for a dog. So, in addition to myself, we have several of our tech group members have helped choose these awards-winning designs. So, would our judges please stand for a moment as I call your names? Please hold the applause until we have been named. Rex Brown. Not sure if he's here. Right there. Rex Brown with Honeywell. Jeff DeGrange. Stand, sir. Peter Reed with Reed & Associates, who is unable to join us here this year. Don Smith with Baxter Healthcare. And I'm basically blinded by these lights, so I hope he's standing. You can stay standing, Rex. Robin Zwick with Boeing. We have Robin over there. Thank you. April Cook with Trump over here. So, again, thank you all for your review, oversight, and participation, making these judging very, very intricate and elaborate decisions. So I appreciate that. Thank you all. For this year's challenge, we encourage the students to create custom automotive aftermarkets. It is our 10th anniversary of doing this competition, and this is also the original entry that we'd done when we started this. Jeff was part of that too. So, of the 9 submissions that we received, an honorable mention, the first runner-up and overall winners were chosen. So, unfortunately, our honorable mention team from The Ohio State University was unable to join us today. Our first runner-up from Texas A&M was comprised of Bradley Lenaway and faculty advisor Dr. Wang Hung. So their project is called the Freedom Tool, a handheld emergency device for use in motor vehicle escapes. In general, the majority of all flood fatalities occur in cars, be it during major storms such as hurricanes or tornadoes, or during severe flash floods. The Freedom Tool's purpose is not only to give the customer peace of mind, but to be the one device a person grabs at a time when they need it most. Here to accept the award for the first runner-up is Texas A&M student Bradley Lenaway. Please join us. Now we'd like to recognize our overall 2018 10th Anniversary Direct Digital Manufacturing Challenge winner from Western Washington University. Team members Kush Sharma, Sean Tui, Eric Lim, Jacob Gannon, and Robert Lafferty, and their faculty advisor, Dr. David Gill. The Western Washington University team created the Vent Buddy system, a smart adjustable vent phone mount. The focus of this product was to create a safe environment for the use of a cell phone while driving, along with easy installation and no residual after removal. The device has a gripper that the customer would be able to push into the car vent, and it is designed for a smartphone of all different sizes. Here to accept the award are the Western Washington University team members. Please come on up to the stage. Robert, Eric, Kush, and Sean. Now I'd like to welcome back Jeff to the podium so that he can take over and lead us through the rest of these. Thank you, Jeff.
Thanks, Carl. Thank you, Carl, and congratulations all to our competition winners out there. Now we'd like to recognize our 2018 Dick Auburn Distinguished Paper Award winners. Thank you to the 2000 Dick Auburn Award sponsor, Rochester Institute of Technology, AM Print, Center for Additive Manufacturing and Multifunctional Printing. This particular award is named after the late Mr. Dick Auburn, who was the founding member of the former Rapid Prototyping Association of SME, and a pioneer in international intelligent manufacturing systems effort. SME's Dick Auburn Distinguished Paper seeks to recognize individuals or groups for advancing the body of knowledge of applications of additive manufacturing processes and techniques. This year's winning paper described a new method of deploying binder jetting with different powders such as silica, alumina, and steel to create multi-material molds. This work goes beyond the scholarly merit but enables parts productions that are said to be impossible to manufacture via sandcasting. This is yet another example of demonstrating how additive manufacturing can solve industry problems. And this year's Design for Additive Manufacturing's multi-sand molds truly embodies the award spirit of innovation and potential impact in the field of additive manufacturing. They're here to accept the 2018 Dick Auburn Distinguished Award paper is the author and presenter, Dr. Lee Neal. Dr. Neal? Join us for the Dick Auburn paper presentation during the Casting 2 conference session from 3:45 to 4:10 in room 201C. Our final award of the day was developed to recognize outstanding accomplishments that have significant impact within the additive manufacturing industry. And the application of additive manufacturing technologies. Previous award winners have included Dr. Hans Langer of EOS, Greg Morris of GE Aviation, Chuck Hall of 3D Systems, and Scott Crump of Stratasys. Before we introduce this year's winner, we would like to recognize previous winners that are with us today. Please stand to be recognized. Andy. Brent. Thank you. And before we introduce this year's award winner, we'd like to thank Stratasys Direct Manufacturing for printing the award. This year's acclaimed Industry Achievement Award winners are Carl Deckard, PhD, of Structured Polymers, and Joseph Beeman, Doctorate in Science, FSME, Ernest Goya, Regents Chair in Engineering for the University of Texas, Austin. Deckard and Beeman are co-inventors of selective laser sintering. As we all know, SLS, are being recognized for their significant and continued impact on the additive manufacturing through the development of processes and technologies applied in the industry. Mr. Deckard, who is the Structured Polymer co-founder and technology officer, conceived and developed the selective laser sintering technology while at the University of Texas, Austin. The concept of selective laser sintering took shape when he was an undergraduate. Mr. Deckard then pursued his master's degree and PhD work. Carl then co-founded Nova Automation, which then renamed into DTM Corporation and then was later acquired by 3D Systems. And with the launch of the Center Station 2000 in 1993, selective laser sintering moved from the research labs to the industry. And in 2012, Mr. Deckard teamed with Jim Mikulik and Vikram Devarjan to found Structured Polymers, a material company focused on improved material properties for selective laser sintering and other powder bed fusion additive processes. Mr. Deckard had also served as an assistant professor of mechanical engineering at Clemson University. And Professor Beeman was one of the founders of the DTM Corporation, now merged with 3D Systems, which markets selective laser sintering. He has also worked extensively with special metals processing industry to develop next-generation process controls for superalloys and titanium alloys. Dr. Beeman is a fellow of both ASME and SME, and he's presently the technical editor of the Journal of Dynamic Systems, Measurement and Control of ASME. He was elected to the National Academy of Engineers in 2013 and received the FAME Award in Additive Manufacturing in 2014. And elected National Academy of Inventors in 2015 and received the SME Albert Sargent Award in 2016. Ladies and gentlemen, please welcome our 2018 Industry Achievement Award winners, Carl and Joe. And how fitting to be in Texas. Thank you, Carl. Thank you, Joseph. Join us for a special presentation from SME's 2018 AM Industry Achievement Award winners, Carl and Joseph, here in the Keynote Theater at 11:30 tomorrow morning. Once again, thanks and congratulations to all our awardees today, and thank you so very much for attending today's session.
Ladies and gentlemen, please welcome to the stage Vice President of Events and Industry Strategy, SME, Debbie Holton, and CEO Rapid News Communication, Duncan Wood.
Good afternoon, everyone. It's our pleasure to be here this afternoon and a pleasure to share the stage with you, Duncan.
It's lovely to be back here again.
That's great. You know, recently, Ellen DeGeneres broke a world record by taking a selfie with a lot of celebrities at one time, and it got millions of shares. Was I think it broke the internet, actually. So today, Duncan and I are going to attempt to set a new world record for a selfie with the most amazing engineers, manufacturers, additive manufacturing people. All these awards, there's celebrities right here, so we're going to give this a try. What do you think? Can we bring the house lights up for a second? Everybody stand up. Oh, it was already on. Give me a second. All right.
You want to do?
Get in the picture. It's going. One more. I like that one. Awesome. Thanks, everybody. Look for that on your social media feed, okay? Don't forget to tag RAPID18. So I'd like to also second the congratulations to the award winners. It's incredibly important to recognize these achievements in our industry. And I'd like to thank our SME member leaders who were just up here. You guys are amazing. Thank you so much for all you do to advance our industry. Fantastic job. All volunteer work. Thank you. So as you saw in the opening video, SME is building a powerhouse community in additive manufacturing. We are better together, and that's true in our industry, and it's true in SME's partnership with the TCT team at Rapid News Publications. And together, we bring you Rapid plus TCT, the most influential and respected event on additive manufacturing in North America. Additive manufacturing technology continues to grow in capability and importance. And as industry organizations, it's our responsibility to reach manufacturers and share our knowledge and understanding of how to fully leverage this technology.
Thanks, Debbie. I'd also like to add my welcome to you all this afternoon. If you're a first-timer here, then you're going to go back to your companies with your mind blown. If you're a veteran of a few Rapids, then it's great to see you again. But don't think there isn't anything for you guys to learn. I've seen the show floor behind us, and you're in for a real treat. There's a lot of new technology, and there are some things that simply make your jaw drop. Debbie mentioned that it's our responsibility to fully leverage this technology. So what does that mean exactly? Well, for a start, we haven't got close. That is a fact. There are so many more companies that need to know what you're about to immerse yourself in. And even then, we know that many of you have a challenge taking what you learn here back to your organizations and getting buy-in for the upper levels in your business. So for that reason, SME and TCT recently announced the Rapid plus TCT Executive Summit. This is a new event designed to ensure that today's manufacturing leaders and executives get the intelligence and insights they need to ensure that the understanding gap between them and the technical experts in their organizations is removed. We hope that it will be another step along the path of enlightenment.
That's great. I'm so excited for that event. It's going to be fantastic. And did you know that if California were a country, that it would be the 7th largest economy in the world? And additive manufacturing is growing there at a rate of over 20% per year. And that's why we're taking this show on the road, October 2019. We will launch a new event, Rapid plus TCT West in Santa Clara, California, reaching a unique West Coast market with the same world-class content and technology that you've come to expect here at Rapid plus TCT. I hope you'll join us.
I hope you will join us too. So the partnership between SME and TCT is flourishing. I think the evidence is in the progress of this event, but also in the new events that are coming. However, Henry Ford perhaps put it best when he said, coming together is a beginning, staying together is a progress, and working together is success. We've made a lot of progress.
Yeah.
And we'll continue to work hard together to bring success to this industry.
Thanks, Duncan. I'm really looking forward to all these new events and working together to make our industry even greater.
So, enough about us. We'd like to hear from you. Before we start this next poll, as Jeff said, to participate, simply go online to Slido and open up the Rapid plus TCT event app and select Slido, I should say. So these are the results from the poll from earlier that Jeff set up.
Right, so we got a little bit of a change. The Forever group went down a little bit, so that's a bummer. But
there's definitely some Forever guys out here that I've seen.
I know they're here because this is the achievement section. But great. So first timers, we've got a special event for you tonight. It's a first timers reception. You should have received a ticket in your badge, and we'll be having that right here in the building from 5 to 6. So we hope you can join us immediately following this. So our next poll question is, everybody get ready, okay? How well does your management understand the benefits of additive manufacturing technology? 1, not at all. 2, a little bit. 3, getting there. 4, sufficiently. 5, brilliantly. What do you think? Let's get some answers in there. It's moving.
It is. So there's hope. It's good to see that a lot of the audience have got support from upper level, but
great.
also you can see there that there's still a lot of need for upper level management to kind of get their head around what you can really do with this technology. So it's interesting results.
It's a work in progress. Bodes well for that executive summit, doesn't it?
Yes, it does.
Great. So we've got another question, so get ready. What is the biggest issue facing additive manufacturing technology adoption? Management, skills, wow, that was quick, financial considerations, certification and regulation, or repeatability?
This one's moving around a little bit.
This is changing. Need the Jeopardy music.
That's kind of what you'd expect.
Yep.
Thought skills might be a little higher. We know that that's an issue across the board, but finance is always a problem, right? It's always a challenge.
That's
so,
right.
And it seems to be brought out by what's showing on there. So.
Yep, financials and ROI, super important. So that's great. I hope you guys like this little piece so you can kind of see what's happening out there in the industry. And we've really seen our industry change and grow in leaps and bounds this year alone. And our next speaker is a leader in that industry. He's a 25-year veteran of the additive manufacturing and 3D printing industry.
From his work as a consultant, writer, author, speaker, editor, and advisor, he does a lot of stuff. He was named as one of TCT's most influential guys in the additive manufacturing industry.
He's president of T.A. Grimm and Associates, which is an additive manufacturing consulting and communications company. He's a friend of SME. He's an advisor for the RAPID and TCT conference, an advisor to the TCT group, and has also served as chairman of SME's Additive Manufacturing Technical Community. And now it's my pleasure. Please join me in welcoming Todd Grimm.
Good afternoon. Are we ready to hear what's new in the world of additive manufacturing? I hope so, because it's going to be a fast-paced presentation. I've done this several years to kick off the RAPID event for 2 purposes. One is to make sure that you're at least somewhat in tune with all the developments and all the activity in the space, but more importantly, to offer you a little bit of navigational guidance for the show floor, which opens tomorrow, because there's so much to see, so much to absorb, so much to understand. I want to give you a little bit of the highlights, so that you have a little bit of direction of what booths you need to go see. Now, in the past, to represent the dynamic nature of this industry and also the speed of this presentation, I've used the metaphor several years ago of drinking from a fire hose. Then I moved it to drinking straight from the hydrant, unregulated by the hose. Last year, I moved to a tsunami or a flood just washing over us. Well, I've run out of metaphors related to water, so this year, I'm going with flame. So years ago, we had ignition. The spark was lit, the match was lit, and then we hit a flash point where everything started to take off, and now we are at a point of time that what's new is an absolute explosion of new solutions for you. Now, I'm going to give you a sampling. This list that appears was cultivated from announcements from October through December of last year. Don't bother memorizing the names. Don't try to write them down. I just want to let these wash over you to give you a sense of how fast this industry is advancing and how fast the new solutions are coming at us. Now, keep in mind, that was fourth quarter of 2017, where half of the quarter is lost to holidays and people with their heads down because you're ending the year. Let me show you what it looks like from January to this Sunday. So here's the list for the most recent quarter. Now, this list represents hardware, software, and materials. It represents early research, late-stage research, beta announcements, and commercial launch of the technologies. So it is all-encompassing, but I want you also to recognize that I did not create a list with the intent of blowing you away. I vetted the list of all of the news that came out in the last 6 months for something appropriate to an industrial professional user. So obviously I can't cover all those in 40 minutes. I'm going to do my best to offer you highlights. And to help me speed things along, I'm going to rely on the ASTM classification system. For the slides where it's appropriate, on the bottom border, you will see icons with abbreviations for each of the processes as a little mental flag of what class it falls into. And those classes are binder jetting, where we're jetting a binding agent onto a bed of powder. Directed energy deposition, where we're directing energy to create, in many cases, a melt pool, and then introducing material into that. We've got a material extrusion, which is probably the one that most people are familiar with, so we're extruding polymers and some others these days. Then you have material jetting, which is very similar to binder jetting, but we're jetting the material that actually goes into the part. Then we have powder bed fusion, a bed of powdered material that's fused, sintered, or melted by an energy source. Then we have sheet lamination, which is laminating sheets of material, cutting the profile and stacking those up layer by layer. And finally, vat photopolymerization, easy for me to say fast, wow, I'm glad I got through that word, where we have a photocurable material that's solidified by exposure to light. And then the kicker, which isn't in ASTM's classification system, is hybrid, where we have one platform that does both additive and subtractive. So remember, the key at the bottom will help you sing along with what I'm going to discuss. So be careful what you ask for. I hope you're ready for what's new, because you're going to have to hang on to your hats, because this is going to be a very fast-paced ride through what's new. We're going to hit 100 miles an hour right now. We're going to start with hardware in the 3D printing or additive manufacturing space that has been released, meaning that you can buy it today or very shortly, matter of weeks or a month or so, have it available in your shop. We're going to start with metals. XJet out of Israel installed their first two machines. The platforms are called Carmel 700 and Carmel 1400. The process is called nanoparticle jetting. They're jetting nanoparticles of metal or nanoparticles of ceramic. That creates a green part, which then goes into a furnace for full sintering. Now, the Carmel 1400 has a 1400 square centimeter working area. The 700 is a little smaller with 700 square centimeters. Now, one thing to note here, XJet has announced the technology, talked about the technology here at RAPID over the last 3 years. So sometimes you have to exercise patience for the new technologies that are coming out, or maybe not. Meld Manufacturing surprised me, popped out of nowhere. They have a machine to show you that they can sell to you today called the B8, with a brand new process for additive manufacturing of metal parts based on friction stir welding. What they're looking to do is overcome some of the challenges and limitations we have with respect to residual stress. This process doesn't have that, and the portfolio of materials that you can use. So using friction stir welding also allows them to use a variety of inputs. They can take powder. They can take recycled chips from your CNC operations. They can take bar stock or tube stock, put it in the machine to create a metal part. They call it solid state because it never hits a melt point. That's what reduces the residual stress. So we expand our material portfolio and also pick up some speed. They claim about 10 times faster than competitive technologies. Oops, I didn't click there. That's Meld. That's the picture of Meld. SLM Solutions, a tried and true player in the metal space, announced the SLM 800 at Formnext in November. This is a large format metal additive manufacturing machine based on the powder bed fusion process. So large format, tricked out with 4 lasers, 700 watts each, and it's built for scalability and integration into an automated workflow. The machine itself is only the right half of that image behind me. All the pre-processing and post-processing equipment and processes are housed in the equipment to the left-hand side. That's to handle unpacking, depowdering, powder handling, all the things that have lots of touch points, lots of labor demands that just drive us crazy and prevent us from moving truly into production. Renishaw, also another tried and true player, is going a little different direction, staying with the size of the machine that they are known for, a medium-sized frame, roughly in the 10-inch by 10-inch range, with a 500Q, Ren AM 500Q. Q stands for quad, so the Ren 500 AM has already existed. They've added 4 lasers, 500 watts, to make the Q. This is all about lowering part cost through efficiency in the operation. It also has the ability to bolt on pre-processing and post-processing automation steps or units to reduce touch labor. Spe3D, new player, going after speed. How does 100 times faster or 1,000 times faster sound to you? How are they doing that? They're borrowing from the cold spray industry, well-established technology where you are firing metal powder at supersonic speeds. When it makes impact, you form a mechanical bond. So they too are eliminating the issue of residual stresses which drive us crazy in many of our technologies, and they're also expanding the material platform or portfolio like Meld Manufacturing has done, to the extent that they will be demonstrating in their booth 11 o'clock and 3 o'clock tomorrow this machine called Lightspeed or Lightspeed 3D, I'm not sure which name they go with for the machine, producing copper parts. And by the way, National Research Council of Canada is also using this technology, playing with magnetic materials to try to 3D print magnets. Sticking with metals, Formaloy. Previously they had the L series. Now they got the X series, which is just being introduced and debuting here at RAPID. This is directed energy deposition technology. The difference on the X series is that they're adding blue laser technology. So IR is infrared is very standard in our industry. They're adding blue laser. Why? Blue is absorbed faster or more readily, so that increases the throughput. They're saying 2 to 10 times faster. It also expands the material portfolio that's available to you. So you're getting speed and expansion material offerings. Digital Metal. This is a business unit or subsidiary of Hoganess, which is a global supplier of metal powder for traditional applications like press and sinter, metal injection molding. For about 6, 7, or 8 years, it's been offering the additive technology as a service. Just late last year, they introduced the DM2500 as a piece of equipment that you can purchase to build your own metal additive manufacturing parts. It's based on the binder jetting technology. So they're going to jet a binding agent onto the metal powder. That creates a green part, which is then taken through a debind process and then taken to a furnace for full sintering, yielding a fully dense part, which is the same exact methodology and process used in press and sinter and the metal injection molding marketplace. They are going after smaller parts, higher precision, finer surface finish. Think in terms of jewelry and watch cases, that sort of thing. Prodways. I don't know if I like this name. They're calling it Rapid Additive Forging, and I don't see any forging in this. It's actually based on electric arc. So a deposition head mounted to a robot in an inert environment, laying down metal material in the inert environment allows them to go after the reactive materials, such as titanium, which happens to be their first partner, their first installations. Target is making titanium parts. Exact Metal. Last year, if you recall, if you were here at RAPID, they introduced us to their low-cost direct metal platform. Now we have product that we can purchase. The XM200C and the XM200S. This is a low price point entry into, for you, low price point entry into the metal additive manufacturing space based on powder bed fusion. To drive the cost down of the equipment, which runs 2 units, one is $80,000, the other is $130,000. They use a gantry method to move the laser head instead of relying on galvos to direct the beam. There's also some other unique twist on how to do the process. Buried in the machine, you can go down to the booth. Oh, by the way, I forgot to tell you that. What are those numbers next to each name? Those are the booth numbers. Boy, I really messed up on that. So to drive you down to talk with these people, jot these booth numbers down and hustle down there tomorrow when the show opens. So $80,000 and $130,000. The only difference between the two is the power of the laser, 200 watt versus 100 watt, and whether it's an inert environment, allowing you to process reactive materials, or if it's not an inert environment. And they also are teasing us that later this year they're going to introduce an industrial class machine called the XM300, which will be much, much larger platform. These machines shown here are about 5 inches by 5 inches with 2 to 4 lasers, but also a higher price point. In the non-metals, we have EOS, who introduced 2 machines. The P810, now this is a high temperature platform. They've had the P800 out for quite some time. The P810 is the successor to the P800. It is a larger format, plastic powder bed fusion system. And interestingly, in the press release, which was embargoed until this morning, so this is news that's just breaking, it was designed around the specific intent to process a material that they call ALM HT23, which is a carbon-loaded PEC material. It also has all the automation components around it to fit into a production environment. They also announced recently the EOS P500, which is the successor to the P396, which is reducing part costs by about 20 to 30% while increasing throughput by 2 times. Now this machine is a little bit interesting because it's a mid-range size, so roughly the 14-inch range for X-axis, but it's also ups the temperature, the operating temperature, into the range of what we used to know for the P800, so it can process up to 300 degrees C, which opens the door to the high-temp materials, such as PEC and PEEK, to be processed on this machine. It's no longer exclusive to the P800 series. HP has 2 announcements. Most recently, the Jet Fusion 300, 500 series. There are 4 machines in this series, 2 for the 300, 2 for the 500. They vary by the number of agents that you can print and also by the size of the envelope. It's a mid-range system for size. Why would we need 8 agents? Well, this is HP's delivery on the promise that we're going to have multi-jet fusion with full color parts. So a detailing agent, a fusing agent, and 6 agents to impart color. The price point for these is very attractive, starts at $50,000 to get you into the jet fusion or multi-jet fusion processes. Then we have Farsoon, going after large plastic powder bed fusion systems, the FS1000P. FS for Farsoon, P for plastic. 1000 stands for the length in the x-axis of the build chamber, so 1,000 millimeters. It is also a reasonably high-temp machine at 220 degrees C, and it's the first time they've introduced or tied into their machine their concept that they call CAMS, Continuous Additive Manufacturing Solution, which again is a modular, scalable solution to bolt on the processes on the back end and front end. And in their statement, it's all about driving the uptime or the production time of the machine, so you never have to sit and wait for something else to happen before you build your next part. Here's something new, and they're not here. This is born out of the Technical University of Vienna. They're calling the process hot lithography. The premise is the photopolymers we have available today are limited in mechanical properties or thermal properties because we have to use less viscous materials to get them to flow to where they want them to go. So what happens to a material when you add a little bit of heat? It becomes less viscous. So they're doing a hot lithography process so that you can use more viscous resins in the 3D printing process, and what they believe that'll do is open the door to material properties not previously available to us in vat photopolymerization. And they also state that by having the hot lithography process, it makes the material more stable and also more reactive. Being more reactive means that you're going to have faster curing, faster build times. Take a look inside the machine. Cartridge-based, they're developing their own materials. Plug the cartridge in, heat it up, rock and roll, build your part. And the last one on this slide is Union Tech. Now, this is a Chinese company that came to the North American market in the last 2 years, has really built a reputation for quality equipment, dependable equipment, and really nice output on their parts at a lower price point. With their latest machine, this is the RS Pro 1400, they're also going after very, very large stereolithography. 1400 for 1400 millimeters. They had to actually build a carbon fiber recoater blade to extend over the 1400 millimeters because they found that metal was deforming in the middle because of the expanse. The next, all on this slide, are the material extrusion class. This one was embargoed till today. Ultimaker, been in the space for a number of years, is coming out with the S5. Now the S5 runs about, for a build area of about 14 by 11 inches, so it's pretty good size. But what caught my attention on this one is it's built for the industrial user. And what they make the statement of is it integrates hardware, software, and material properties. What the heck does that mean? Well, what it means is it's not up to you as a user to work with the hardware, figure out the material properties that will actually work to build your part, and tie that all together with third-party software, so they're building an entire package, a solution that aids in predictability and routine performance where you don't have the doubt that something will or won't build. They're also adding lots of industrial-grade hardware inside of the equipment for reliability and uptime. Another company tackling the industrial market for material extrusion is Fusion 3. They're here in booth number 1704. Their machine is called the F410. Really reasonable price point, $4,500. running in the 14 by 14 inch build area. And it does have a enclosed chamber. It's not going to maintain high temperatures, but it will maintain temperatures up to 45 degrees C, which helps with managing stresses that can cause deformation in your material extrusion parts. Titan Robotics. I believe is this what Titan Robotics printed? I believe so. They've announced that they're turning to industrial motion controls from a world-renowned leader to give you faster operation with precise control of the deposition head. So you get speed and accuracy using these industrial motion controls. You also get a feedback loop for predicting and preventing material jams. Now this is not, their line of equipment is called Atlas, and these are not small desktop machines. Atlas runs upwards of 4 foot by 4 foot by 4 foot build area, and you have the option to have open chamber exposed to ambient temperature and also enclosed thermally controlled chamber. Essentium, it's actually Essentium Materials, has come out with a machine called the HSE, high speed extrusion. They're picking up most of their speed not by a bigger orifice and dumping more material through, but by faster tracking of the deposition head across the XY area. This one's interesting because they have patented technology that prior was a bolt-on to be added onto other people's equipment. It's called flash fuse. They're using a material that's coated with nanoparticles, and then they're imparting, as you can see the little purple area, they're using plasma to send an electrical charge which activates that coating of the nanoparticles, which creates localized heating, which increases the Z-bond strength. Also with this, they're claiming about 10 times performance increase based on other material extrusion systems. And then finally, the contributor of our lovely icons, Hybrid Manufacturing Technologies, I see Jason right here in the audience, has announced the PE1. Now this is a polymer extrusion, hence PE, polymer extrusion head. It's unique in that it is outfitted or works with the company's Ambit solution, which is a tool-changing solution that combines additive heads, subtractive heads, and inspection heads, and can be added to an existing CNC platform, so you pick up true hybrid operations. The company has been offering the solution for a number of years. Previously, it's focused on the directed energy deposition technologies or laser metal deposition. Now it's into polymer extrusion. This is pellet fed and pumping out upwards of 20 pounds of material an hour. So we're going to kick over into what's been announced but not available. So we're getting a little peek into the future. 3D Curax, they're not here at the show. However, they were kind enough to allow RAPID to be the first event here in this presentation to publicly expose what's going on. They've actually launched their website timed with this presentation, so you can go to 3dcurax.com and see what they're all about. These guys are attacking production. They want to disrupt the injection molding marketplace. They're using LCD panels, backlit, so imagine DLP, but using LCD. The reason for that, LCD panels come in larger formats, gives you scalability. Two machines available, the MRK3 and the MRK10. The 3 has a XY working area of a little over 400 square inches. I'm guessing that's going to translate to about 25 inches by 15 inches for XY. The Mark 10 is 10 times bigger, so 4,000 square inches of working space, which is going to get you into probably roughly the 70 to 80 inch range for at least one of the axes. Now, to attack the injection molding market head on, they're looking at speed. If you go with the Mark 10, build an impeller about 2.5 inches in diameter, 1 inch high, that's a 30-minute build. But you can fit 722 of those impellers in the Mark 10, which breaks down to a throughput time on this machine of 2.5 seconds each, which is very, very competitive, actually best the injection molding marketplace. However, they're not sticking with just a machine. As you can see here, they're thinking in broad terms and automating the entire process, adding artificial intelligence, adding robotics, adding artificial intelligence to optimize the build to get the most out of it, taking you all the way through to cleaning and curing and post-support removal in an automated fashion. Next up, Evolve Additive Solutions. This is a spin-off or spin-out of Stratasys. The news came out, I believe, is about a month or two ago. The process is called STEP, and I'm going to walk you through that terminology so you understand what's going on. STEP stands for selective. We can scratch that. That's a unneeded word. The next word is thermoplastic. So this is not the metal solution that Stratasys has hinted at. Instead, it's thermoplastics. It's able to process both amorphous and semi-crystalline materials. The next word is electrophotographic. And if you're from the 2D printing world, you'll know what that term means. It's used in high-speed, high-volume, multicolor printing. And Evolve has actually partnered with a company that has been putting those units in place for a number of years. Electrophotographic, to boil it all down to the simplest terms, a drum spinning that's electrically charged, powder that's also electrically charged, the opposite charge, which is attracted to the drum one layer profile at a time, transferred a little bit of heat, a little bit of pressure, and you have your 3D printed parts. Now they are claiming, and I believe this to be true, I saw this back in May of last year, early prototype machine, they're claiming speeds 50 times faster. But 50 times faster than the fastest powder bed fusion technologies on the market today. They're claiming near isotropic properties, they're claiming surface finish that rivals injection molding, and they too, like 3D Curax, are going right at the heart of the production technologies that we know today. Another new one, MVP, Magnum Venus Products in collaboration with Oak Ridge National Labs. Large format, 16 foot by 8 foot gantry-based system to produce additive manufacturing parts in thermoset materials. That's the first time you've heard that combination of large and thermoset. The company is a supplier of equipment for the composite part-making industry, so their target right now is to use the benefits of thermoset, meaning that they're not going to melt in an oven or an autoclave, to make the molds to make the composite parts. Aerosint. Machine's just a rendering, it doesn't exist yet. They're looking at tackling a problem that we have with powder bed fusion, which is single material. You roll or scrape or recoat a powder, it fills the entire working envelope with one material. What they're doing is coming up with a 2-drum system, depositing the metal or the powder on a voxel by voxel basis. They're looking long-term at attacking plastics, metals, and ceramics. But short-term, they're going to go after plastics, and they're going to take on one of the issues that we have in powder bed fusion, which is recycling rates. All that excess material in the machine that is just supporting or holding in place the part is exposed to temperature, which causes thermal degradation, which means that you can't use it over and over again. Well, the second material they're going to deposit is a non-fusing material, which means that you can recycle it unlimited, so you're not losing money by material that you can never touch. Next one up, this one is announced. It's really available right now, but since the company doesn't sell direct to you, the end user, but sells to OEMs of equipment, that's why I'm saying it's announced. So Strong Press is exclusively licensed Oak Ridge National Labs technology for multi-diameter orifice extrusion heads. What that means is on the fly, you can go from small diameter for high precision, fine detail, and then open it up on the same build on the fly with a larger diameter to backfill to give you quality, precision, and also speed. And finally, New Pro 3D. Just saw them in the back here, shook their hands. This is a continuous DLP process, so think in terms of what Carbon is doing, think in terms of what 3D Systems is doing. It's another alternative for the continuously draw your part up out of a vat of photopolymer. Their machine is called the MP1. They've introduced the technology over the last couple of years, but come October of this year, you'll be able to take delivery of the MP1 system. That's why I put them in the announced category. Hardware announced in the metal category. First up, GE Additive with 3 things. Tomorrow at 11 o'clock, they will unveil the Spectra H. This is electron beam melting, EBM. This is a larger format machine, higher temperature machine, and also one that will process titanium aluminide, which has been done, but on a case-by-case basis for those kind of people that want to experiment and make a technology do something that it shouldn't. Now you'll have TiAl available as a commercial solution. I don't know if the launch is tomorrow is going to mean that you can buy a machine tomorrow and take delivery, or if it's just being announced. You'll have to stop by their booth at 11 o'clock to understand what the position of that technology is. They've also announced November of last year, Project H1 or H1. You're seeing here, this is a binder jetting solution for metal 3D printing. They're going after large parts and dense parts, specifically attacking the casting market. So binder jetting onto a bed of metal powder. You will take that into a furnace cycle. I suspect that they're going to be infiltrating. I don't know this for a fact just because large, thick-walled parts do really, really funky things if you try to take them to a fully dense part in the sintering furnace. But you'll have to ask GE Additive what it really means. And then finally, they announced their first platform based on Project Atlas. Additive Technologies Large Area Solutions, that's what Atlas stands for. And this is what they're calling a meter class metal additive manufacturing machine. Meter class meaning 1 meter by 1 meter and up to 1 meter depth. Not a lot of details other than it's a gantry-based system. So instead of using galvos and mirrors, we're directing it from a gantry. And they have to, because it's so big, to prevent you from having all that inventory of material, they're actually using discrete dosing in the machine. How that works, what it means to us, I have absolutely no clue because they were very, very secretive on their unveil at Formnext. You'll have to ask them and try to dig out details. AIM 3D is an alternative for extrusion to create metal parts. They got a machine called the EXA 255. What's interesting with this, so this is combining thermoplastic with metal powder, which is then fired in an oven. What's interesting for them is they're using pellet fed and somehow mixing the metal powder to get higher speeds, higher throughput for metal parts. A company called Colido is also doing the extrusion of metal-infused thermoplastics with their machine. Their process is called AMSS for Additive Manufacturing Selective Sintering. We also are seeing progress in supporting equipment, and I'm going to pull up all three of them here, which is good news for us on the back end. Automation, automation, automation. I've just got a system shown up here. That's not what's new. That's from Post-Process Technologies. But what is new from Post-Process Technologies? Something called Connected. Imagine walking up to a screen and selecting, I want surface finish. Here's the surface finish I want, and then clicking a toggle for if you want support removal or not, and then selecting the file and letting the process rock and roll. Whether it's daisy-chained with multiple pieces of their technology or not, it takes care of it in the background, playing to the digital thread. AMT, Additive Manufacturing Technology, exclusive licensee of the PUSH technology out of the University of Sheffield. This is a chemical process for processing powder bed fusion parts from processes come from EOS, 3D Systems, and HP. No details on how it works, but what their claim is, injection molding quality parts at the push of a button. Oops, and then finally, I got to go back on this one, Roessler Benelux has mechanical finishing solutions. They've designed some equipment from the ground up, specifically for automating the post-processing of additive manufacturing parts. For a little bit of taste, just to see what the future holds, a little bit of excitement, Lawrence Livermore National Labs, process called volumetric 3D printing. So currently, the best we have is project one plane of light to cure a single layer at a time or continuously. What Lawrence Livermore is doing is projecting light from the the Z-axis, X-axis, and Y-axis simultaneously. Where they intersect, there's enough energy to cure. These small little cubes that are hard to see in this image took 10 seconds a piece to make. Challenges with complex geometry, but who knows what the future holds with that. Oregon State University with liquid metal printing, taking a metal that's liquid at room temperature, combining that with nanoparticles of nickel to create a material that's extrudable and has some substance. Although I'm showing parts here, they seem to be focusing on flexible electronics because the output actually will flex, bend, and give. Finally, MIT, they've had lots of new technology for us. Now we've got a fast material extrusion process looking purely at the speed of the head in the extrusion. So instead of just tracking, this bad boy, if you'll watch the video, is just, and that's by lower mass in the head. It's also by higher pressures of the screw that drives the filament and using a laser to impart the energy to reach the semi-molten state. The other thing that they have up their sleeve, working with steel case, is rapid liquid printing is what they're calling it. Cube of gel, a syringe injected into the gel, thermoset material extrudes out of the syringe into this gel, which supports the whole assembly to rapidly create thermoset parts. A tabletop of about 2.5 feet in diameter by about 2 inches tall, 28 minutes. But this is all early research. Who knows where it'll come? Wanted to give you a little taste of what the future holds. Materials, I've already introduced some of the new materials, and I'm not going to get into everything new on the show floor because a lot of it boils down to getting into the details of this tensile strength or this processing speed, which would just drag this presentation out. So you're going to have to discover those yourself, but there are some that are easy to describe that I'll do very quickly. Stratasys, which has long had for its FDM process, Ultem material, has introduced a PEC material called Antero 800NA. So they brought PEC to us in the extrusion, which is, others are doing it, but now that they have it. Prodways, polyamide 6, 6.6, 612, or some of the commercial grades of nylon that you can use in industrial context. Prodways is bringing us the first iteration for powder bed fusion of a nylon or polyamide 612, loading it with glass bead. BASF, 3 different lines, one for powder bed fusion, one for vat photopolymerization, and one for material extrusion. For powder bed fusion, it's called Ultracint is their brand name. They brought out 2 flavors of PA6, an X085 and X043. Don't know the difference between those, you have to investigate. The photoresin for vat photopolymerization, which is custom designed for bottom-up vat photopolymerization processes, so we're illuminating with a laser or a DLP light source from the bottom. And then finally, in the extrusion category is Ultrafuse Z, which is the nanomaterial coated filament that is being used by Centium, who I reported on earlier. Also in materials, LPW, working with a partner that happens to produce tantalum. They're looking to bring tantalum powder to the powder bed fusion marketplace, something we've never seen before. Elementum 3D, aluminum for powder bed fusion, but aluminum 6061. It's been talked about, we've seen research, we've seen proof of concept. Now we have commercial product that cracks the code on the issue of columnar grains creating cracking in the aluminum 6061 parts in the powder bed fusion process. So we now have the door open to a new class of aluminum, which is engineering grade instead of casting grade. And finally, Tethon in materials, Tethon 3D has something called ferrolite. Ferrolite is a photopolymer loaded with iron particles. Now, I don't know if they're trying to increase the mechanical or electrical or thermal characteristics of the part by loading it with iron, or if they're planning on using that as a green part, which is then fired in an oven and sintered. You'll have to invest, if you're interested in iron, you'll have to stop by their booth and see what they're doing and what their plans are for what kind of parts they're going to produce. Then in software, I'm going to be real quick here. Good news is that we've got a lot going on in software to help each of us as users in the area of design, predictability, control, and analysis. In design, Fathom came up with an open source program called Crystalon for development of lattice structures for lightweighting. Open source, meaning that everybody can contribute to advance the technology, and open source, I believe, means that it's free. It's based on the Rhino 3D platform. Oops. Desktop Metal. They're here to show their metal additive manufacturing technology, but what's new from them is collaboration with Dassault on a product called Live Design. Their goal is to simplify and automate the concept of generative design so you don't have to be an expert at that concept. Generative design is where you establish the working envelope that's allowable, plus your mechanical, electrical, or thermal loads, and let the software do its thing and create the part from the ground up. Paramatter, company I saw just 2 weeks ago. Generative design and topology optimization with some advantages over others. What they talk about is intelligent output. Intelligent output meaning that after you go through the simulation and the generative design, what comes out first cut is what can go right into a 3D printer, which is not always true with generative design. A lot of times with current state of the technology, you have to take that mesh model that outputs back into CAD, modify it. In their case, they're looking at the materials you're using, the process you're using, to come up with a design that is compatible, considering supports and other things, with a 3D printing process. They're also considering factors I haven't heard before, such as natural frequency. So if you're interested in vibration on the mechanical component, they're taking that into consideration and other elements. And also for lightweighting, you'll see lattice structure is the commonly used approach. For them, they're using topology optimization within a part, so imagine organic biomimicry shapes for the inside of the part to lightweight it instead of these rigid geometric shapes. Stratasys, 2 things, one released, one in beta. The released is voxel printing off of the GrabCAD platform. This is to drive their color 3D printing on the PolyJet technology, allowing you now to have the tools in CAD to define material or material properties on a voxel by voxel basis. So truly unlocking the potential to allow a part to vary throughout in color or mechanical properties. The other one is, this could be boring for many people, fixture and jig and fixture design in GrabCAD. They're embedding the application intelligence in the software program with the assumption that the manufacturing engineers may not live with CAD day in and day out and have high degree of competence and may not understand all the ins and outs of additive manufacturing. So they're opening the door to doing more jigs and fixtures by embedding the intelligence in the software to allow someone who doesn't live and breathe this to be able to execute. Atlas 3D has a concept. This is for simulation, so this is about predictability, putting parts in and having a high degree of confidence that good parts are going to come out. They're using a concept for simulation, for orientation and support generation, using simulation based on something they're calling thermal circuit network. So they're parsing thermally similar layers. What that means is good data, good analysis with reasonable speed because they're taking large sets of data instead of looking at on a point basis or looking at it a macro basis. Genoa 3D, simulation also. I didn't realize they were a player about 4 or 5 years ago. Helped Oak Ridge National Labs with the BAM technology and Local Motors 3D print the car by modeling the BAM process and predicting what was going to happen based on the parameters they're going to use. Well, they've now taken that process modeling and simulation to the metal additive manufacturing world. Senval, face staring at me right there, is looking at machine learning, a project with the U.S. Navy to come up with analysis and data for statistically quantifiable material properties based on the parameters that you're using for your machine. So again, I know what's going to happen instead of lots of trial and error and lots of guesswork. ANSYS, who acquired a company called 3D Sim, which is a friend of SME, the company is, and also the leader, Brett Stucker, acquired them, and it's a simulation. It was a simulation company. They now have 2 products, Additive Print and Additive Studio. Additive Print does all the simulation to predict stresses and deformations so you can properly design and support your parts. Additive Studio does that, plus CAD modeling, complete workflow through CAD modeling, cleanup, topology optimization, and light weighting. Other software, Link 3D. This is a portal solution so that you can do distributed manufacturing across multiple unowned contact points. They introduced Digital Factory, which is a workflow solution for you to manage and observe what's going on amongst these third parties that are building your parts. But really interesting, most recently they announced blockchain technology to protect your valuable IP. Blockchain so somebody can't access nor manipulate your data in the additive manufacturing environment. We have RISE with digitally augmented parts, embedded markers in your additive manufacturing part, playing to the digital thread. So the embedded marker, such as a QR code, can be scanned to trace back to original design data, original processing data, and tied forward to whatever else you're going to do in the process chain. SLM solutions with Additive Designer, workflow solution with guidance along the process chain, but hooks into your PLM system. Roles and rights management, so those that shouldn't be touching the data and doing something can't, and then also optimization, including modifying the build parameters for the metal additive manufacturing process to eliminate the need for supports and certain features. 3D Systems came out with 3D Connect, a solution for proactive and preventative maintenance, so monitoring the machine status so people can jump in and tackle possible problems or problems right now to keep production rolling. And EOS with EOS Connect, also a connection solution to manage and monitor the workflow when you have multiple machines. And with this one, an interesting twist on it is they're tying forward to computer-aided quality systems. 3D scanning, I'm going to be very quick. This information is, because I'm over my time, is complements of Direct Dimensions, an exhibitor here at the show and also a friend of SME and Rapid. Faro has a new ScanArm 2.0. It's lighter, more ergonomic, but also more accurate than the previous ScanArm. Its intent is to be used, it's designed for the intent to be used in the design environment. Booth number 518. Shape Grabber, well, and that comes with a blue laser. So we've gone from red lasers to blue lasers in the 3D scanning world. Shape Grabber has a new head, That's green laser. And what that advantage is, it's high speed, 800,000 points per second, but the green laser is better, they claim, for plastic surfaces with a high gloss or reflective surfaces. Creaform, a company that came in with the HandyScan, which is a handheld scanner years and years ago, is now going to the other extreme with the Cube R, which is a turnkey standalone system for the shop floor for inspection. It's a robotic arm with their MetroScan, meant for simplicity and ease of use. Zeiss coming out with their version 2.0 of the L3D scanner, which is a blue light fringe scanner, ultra compact, 5 million to 8 million pixels captured. Artec, and this will be seen at the Direct Dimensions booth. Artec is not here. The Leo, Artec Leo, which is a handheld scanner, onboard processing. So it's untethered. You don't need a computer. So scan with a display and see what you're capturing, and much of the processing is actually going on the handheld scanner. And then also the Artec Ray. This is for long range, 110 meters, high resolution, full color, as with the Leo, full color, and high accuracy, out to 110 meters. Verisurf for software. Trend here is to tie everything together. What they're looking at is metrology, reverse engineering, and inspection automation. And the key concept of this is universal CMM, which means that 3D scanning software is no longer allocated to just 3D scanning. It's also working with the conventional stationary granite bed CMMs to tie the whole process together. And Wenzel. You want to stop by the booth. They've got a new CT scanner, the Exact U. More energy, larger build envelope. The reason I say you want to stop by and show them some love is they are going to be demonstrating CT scanning in booth number 518, and they had to jump through hoops with the state of Texas to get the permission to run that machine here at Rapid. So what's new? Much, much, much more than I could cover here today. Companies like this have things that you need to see that are new, truly new, and being introduced, but I just don't have the time to cover them. The last thing I want to mention is that you've made a wise choice to be here at Rapid. There's a lot coming at us, opening new solutions, new opportunities, new applications, but it has the very real danger of just swamping us and inundating us. But you're here at Rapid where you can go see and go talk to the players to understand what those solutions can do for you so that you can ride the wave of innovation instead of being swamped by it. And the last comment, if you're walking through the show floor and you see a 76-inch tall surfboard, you may want to stop by that booth and ask, how long did it take? Just a little teaser. I'd love to tell you more, but it didn't make my criteria for what's new at Rapid 2018. Ladies and gentlemen, thank you very much for your rapt attention. I wish you all the best in your journeys over the next 3 days at the Rapid Show. Thank you very much.
Center stage photo here. Thank you very much for a super informative presentation. I know everybody loved it.
My pleasure.
Thank you very much.
And I hope you enjoyed it. Thank you.
All right.
Where's the photographer at?
Okay.
We got it?
To get your own photos. Okay, perfect. Thank you.
Thank you very much.
Thank you. Great. That was so amazing. So much is happening in this industry. It's insane, right? So now I would like to introduce Mohsen Saifi, who's the Director of Global Additive Manufacturing from ASTM. And he has a special announcement that we're very excited about because it's something that SME is involved in as well. Please help me welcome Mohsen to the stage.
Good afternoon, everybody. Thank you, SME, for the opportunity, and it is my pleasure to speak with you today. My name is Mohsen Saifi. I'm Director of Global Additive Manufacturing Programs at ASTM International. Last month, we announced our first ever established Center of Excellence in the history of ASTM International and perhaps any other SDOs. And this is a strong and huge step toward enabling manufacturing innovation and accelerating commercialization of additive manufacturing. The COE that we announced support our activities in pre-standardization as well as standards development. And here's why. We believe AM standards development and advancements are not happening fast enough to keep up with the pace of rapid pace of AM technology development. In addition, current ad hoc approach results in standards gaps and duplication, inconsistent standards R&D across industries and geographies, no dedicated workforce to drive R&D for standards development, and finally, lack of global acceptance of standards. And that's why we have created ASTM Additive Manufacturing Center of Excellence to address this need to bridge the standards development with R&D to better enable efficient development of standards, but also supporting education and training, certification, and proficiency testing programs. The COE conducts standards-related R&D to advance technical and data-driven standards across all aspects of AM and AM markets. Fast-track standards development can be accomplished through the COE and ultimately accelerate adoption of cost-efficient additive manufacturing technologies across the industry. Our selected partners have passed an extreme review process. Based on the recommendation of diverse review panel, EWI, Auburn University, and NASA have been selected from a large pool of candidates and applicants. To complement this mix, we will announce the winner of another COE partner next month outside of the US. And here are the rules of each of the partner in the COE that you can see. ASTM will continue to serve as a facilitator of standards development and coordinator of R&D. We will utilize existing roadmaps, such as the one that ANSI in America makes, put together, known as an AMSC roadmap. In fact, tomorrow there is a public meeting regarding the latest status of this roadmap. EWI is building standard-focused industry consortia to identify the needs of various sectors, such as aerospace, medical, and automotive, and other industry sectors. In addition to research and development, Auburn University will develop education and training programs. And finally, NASA is providing their vast expertise in conducting R&D for standardization and certification in the aerospace and aviation sector. In terms of mechanism, here's how it works. COE will be supported by AST International, industry consortia, and government funding. R&D development planning happens across all 4 organizations with ASTM coordination. R&D will be conducted at EWI and Auburn University to feed into standard development process, and finally, implementation by industry use, certification, training, and proficiency testing programs. So with that, I'll stop here indicating that in addition to myself, Frank Medina from EWI, Mike Ogles from Auburn University, and Kristen Morgan from NASA will be attending this meeting and available for whoever you would like to stay in touch and hear more about this activity. Thank you very much.
Right? There's so many things happening. So before we go any further, I would like to thank Stratasys for sponsoring today's keynote. And I'd like you to check this out. Please help me welcome to the stage Rich Garrity, President of the Americas for Stratasys.
Thank you, Debbie, and good afternoon, everyone. It's great to be here in sunny Fort Worth, Texas. I'm coming from Minneapolis, Minnesota, where we had 1.5 feet of snow last weekend, literally, and have had the snowiest April that we've ever had on record. So great to be here and seeing all of you, and looking forward to a great week together. We all know that additive manufacturing is continuing to progress from the prototyping labs to the shop floors, now to even flyaway parts. But did you know that additive manufacturing is also having a big impact on industries as far-reaching as Hollywood and even in the Winter Games that just took place in Seoul? How many of you recognize this guy? Okay, about 10% of you. This is a character named Monkey from the movie Kubo and the Two Strings, a stop-motion animation film that was created by LAIKA. And Monkey and many other characters in this film came to life with never-seen-before realism thanks to 3D printing. This movie in 2016 was nominated for an Academy Award for Best Animated Feature Film. How many of you had a chance to see the Luge team compete in the Winter Olympics? Okay, about 20% of the room. The Luge team for the United States also used 3D printing to gain a competitive edge in getting ready for and actually performing during the Olympics. This was the first games that the U.S. received a medal in the men's single luge competition. We're fortunate to be joined in a few minutes by both LAIKA and Team USA to hear more about their amazing stories and how 3D printing is giving them a competitive edge. I think when you hear their stories, you're going to hear a similar theme around a spirit of innovation which exists within these organizations and how they're pushing new bounds, whether it's going for Academy Awards or going for gold medals. And I think that spirit of innovation is not unlike what many of us are seeing and experiencing in this room today. We all see in different industries rapid amounts of change, digital transformation, AI, big data, analytics, all changing the way that we do things. And it's organizations, whether it's business to business or competing for medals or competing for Academy Awards, that push the boundaries of the possible with new ideas, new methods, new products that ultimately drive them to new levels. This type of spirit is increasingly important in our ever-changing global economy. I think we all feel similar pressures from our customers or consumers that are looking for new ideas, new ways of doing things, and how do we bring those new ideas to market much faster with a greater degree of personalization and performance? How do we evolve our business models to match the changing way that our customers and consumers want to buy from us? How do we optimize our supply chains and manufacturing methods to take advantage of all of the great digital technology that exists today? Increasingly, we see companies turning to 3D printing and additive manufacturing as a catalyst for innovation and a necessary tool in the toolbox to be better competitors. And we at Stratasys have been learning this with our customers for the better part of 3 decades. We're proud to work with over 18,000 customers worldwide. We see our mission at Stratasys to innovate additive technology so our customers can innovate their business, no matter what their business is. And at this year's RAPID, we're pleased to announce several new innovations from Stratasys. The first is taking color rapid prototyping to a whole new level with the newly announced enhanced J750 and new J735 color printing solution from Stratasys. We now have over 500,000 color combinations, highly accurate color matching, and clear with texture functionality coming out of this solution. Prototypes coming off of these printers literally look like the finished product. We're seeing companies not having to do timely and expensive post-processing on these, and they're able to use these like the final product to get a real effect of prototyping. We're going to hear more about how LAIKA is doing this in movie making. And here's a quote from Audi, who's using these solutions now for creating transparent, multicolor covers for taillights. This is typically a multi-step process that is being now reduced to a matter of days and weeks with printing directly off of these solutions. The output is so fantastic that it's actually meeting the design approval processes within Audi. Moving from color prototyping to expanding the range of manufacturing use cases that we see in the transportation industries, we're pleased to announce a new Antero material, which is the first in a new family of PEC materials for FDM. This is a material that brings the benefit of additive manufacturing, the design freedom enabling lighter parts, but providing strong heat and chemical resistance and an ability to withstand high mechanical loads. We're pleased to announce that Lockheed Martin is leveraging this new material in working with NASA's Orion mission to send astronauts to the moon and beyond. This mission will use more than 100 3D printed production parts on board, including this intricately designed docking hatch door, which consists of 6 different 3D printed components. This is a crucial hatch door that allows the astronauts to travel back and forth through the different modules. Lockheed is very pleased with the properties that they're seeing, and equally important, the repeatability in the process itself, such to the point that they're commenting that they're starting to rethink their production strategy on how they make spacecraft more affordable and faster to produce thanks to these new materials and processes. And speaking of manufacturing and the processes, we're also pleased to announce our latest Fortis 900 production printer. This is the 3rd generation of the F900, and the F900 is now become a mature production technology. This solution brings together the hardware, software, and process documentation to ensure repeatability from the first part to the 1,000th part, and includes MT Connect interface to plug into factory floor systems to provide the data that manufacturers are looking for from the system. We also have quality management systems on board, all of which roll up to a solution that provides manufacturers much more confidence in knowing what they're going to get, resulting in increased uptime and reduced risk. Furthermore, in the aerospace industry, we have an additional variation of the production printer that's now producing certified flight hardware that comes with the complete material and process traceability and a robust statistical data set. This was developed in collaboration with NIAIR and was overseen by the FAA. So I encourage all of you to take time this week to come by our Stratasys booth, booth 1104, here in the show hall, to learn more about these exciting innovations from Stratasys. And like our partners on the racetrack, Penske and McLaren, we encourage all of you to gain the competitive edge in making it with Stratasys. Now, let's hear how additive is being used to drive a competitive edge for Team USA. Please join me in welcoming US Luge Technical Director, John Owen.
Who knew 3D printing could be so exciting? US Luge, we are the Olympic sport of luge. That's right, it's the little sled, you know, that ties underneath you. We go down the track 80, 90 miles an hour, pulling 5 Gs as we go down the course of the track. And we are timed to the 1,000th of a second. Now, just as an idea, this is what I've been told. Now, I have no idea how real it is, but I've been told that the sound of the snap of a finger is about 1/100th of a second. And so we have multiple runs down the track, timed to the 1/1000th of a second, and we still can have a tie in our competitions. So everything we do in our sport, in our clothing, and in the design of our equipment has to maximize everything for aerodynamics. Now, not only do we go down the track fast, but the technology changes just as quick. Okay, so I'm going to be showing you some of how we've used 3D printing, additive manufacturing, whatever term you want to give to it, in the process of designing sleds that we have used in competition. And the reason I can do this is because the technology has already changed so fast, what I'm showing you is already out of date. And if I told you what we're actually doing now, I'd probably have to kill everybody in the room, and that really wouldn't work out well for anybody. So this is not a cutting, I'm not giving you the real secrets, but in 4 years in Beijing, which is somewhere in the neighborhood of about 1,370 some odd days, not that we're really counting plus or minus, you'll be seeing us competing in Beijing, and some of the ideas, second generation, third generation of what I'm talking to you about now, will be in place then. So luge, yes, it's that small little sled. We have a small little building envelope. Some of you have seen it on the track. However, this is what a luge sled looks like to me. Sometimes I feel like I'm sort of in the matrix, with the little binary numbers all coming down in front of me, because that's what my job is. I'm the technical director. I have to take all of the ideas that all the coaching staff that we have at the different levels, try to synthesize it into a program and come up with the new parts. And so I'm always looking at engineering numbers, working with Stratasys and our other development partners to come up with new sleds. So how do we come about this? How do we do this? This is doubles luge. If you've never seen luge, there's singles and doubles. One man to, actually, one person, one man or one woman, and then there's doubles. This is doubles here. And so you can see we don't have a very big build envelope to work in as far as aerodynamics go. But 1/1000th of a second. Keep that in the back of your mind with everything that we're looking at doing. So we have to get all these bodies to fit. And going down the track, so these things have to fit. Going down the track at 80 miles an hour, pulling 4 Gs, bouncing around, and still being able to functionally work on the sled. And so little things matter. Okay, now we could design sleds, and we have done it before, in your basic CAD program. A couple of splines here, an arc there, you connect it all with a line, and then you mirror it, and you have a perfectly symmetrical part. We've all done that in CAD design. The only problem is the human body is not symmetrical. Okay, we are organic, so the sleds have to fit better because 1/1000th of a second. So if you look at this top piece here that I've sort of got in the big magnifying glass there, it has to fit with all of these bodies. So in the design process, we take the ideas. The coaches actually will make a prototype. They'll actually make the first piece around the athletes, and we'll go into a wind tunnel and test it, because after all, if you're actually making something new and you haven't tested it and it's slower, what good is making it? So we actually bring it in the wind tunnel and test it. Then here comes the trick. We have to have that flexibility in the design, see if it works, and then we have to turn it and burn it and get it on the track in time for the winter, the next season, with enough time for the athletes to be on it and be comfortable before the competition season starts. Because we're not just making a part that gets placed into a car somewhere. These are real people. These are athletes who are riding the sled, so we have to take care of the sports psychology component of it as well. So in the old ways, I say old ways because we're moving along with your technology. This, to some of you in the composite world, would look very familiar. It's sort of an older school sort of composite mold where you lay up your fiberglass and do that stuff. And with the front part that I showed you on the screen, it's very organic. There's a lot of shapes. So we can end up having, 3, 4, 5. We've even had one mold that was a 6-part mold. And so if you're putting that much energy into creating a mold to build a sled, you really end up with a one-size-fits-all, because you cannot do that and turn it around fast enough for each individual athlete. So this is the way we used to do it. Now what do? Now we go into the wind tunnel, we make the part, and with the technology that's developing so quickly as well in 3D scanning, we scan the sled, the actual sled that's in the wind tunnel that we know worked better, that the athletes are on. We scan it, and what do you get instantly out of a scan? You get a great little CAD model. So we have the design there. We have the part right there. We clean up the design a little bit, and voila. Within literally a matter of maybe days, if that, we can start printing, and we can print ourselves a mold to build a new sled, and possibly a mannequin as well. And since we're saving so much time, we can make things a little bit newer, where we can make things fit better. Instead of making that one-size-fits-all, this is actually a mold that we made with interchangeable parts, so we can extend the size of it. So if you have a little longer team or a little shorter body, you can mix it and match it and make it work a little bit better that way. Now, coming back to that front piece, okay, the front piece is very interesting because there's so many parts to it. The way we ended up changing that, and I actually ran across the guys from Stratasys a couple years ago at the IMTS show up in Chicago. If you've never been to it, it's a wonderful manufacturing show. And I ran across them in the innovation thing, and the second I saw what they could do with sacrificial molding, I instantly knew the part I wanted to make with them, and this is the part. So it's that front nose cone that you see on the double sled. It has to fit all those body parts coming through it. One leg a little bigger, one leg a little smaller. It has to be comfortable. And so we're using their material, the sacrificial material. We print it. Only takes a couple of days. We print it. And you can see it's a very complex part. But then we just wrap it with glass. We do your basic composite layup on it. And then we have a part. We throw it back. They wash out the sacrificial material. We have the hollow part we need. We even had them make a trim mold for it so that we could cut it, and voila. Prototype to finished product within a matter of weeks. And in our sport, weeks matter. We're in the wind tunnel in June, and our sleds have to be on ice in September. So we have to turn the designs within a matter of weeks. This one was done in less than 6 weeks, and I was on vacation for half of it. That's how easy it went. There's another part on the sled, and again, I'm picking on doubles because that's what we mostly have worked on in the last little bit, and it's also incredibly complex, is what you have here is the runner, okay, that's called a Kufen. It's a German sport. We still use a lot of the German terms in the sport. So if you can say Gesundheit, now you have Kufen, you now have 2 German words in your vocabulary. We're getting smarter every day. So the Kufen, as you come up through the front horn where the legs are, those have to fit. They functionally have to drive, and they functionally have to be comfortable on the sled with what they're doing. So how do we do that? Again, we prototype it, we print it, do a composite wrap for each team. If the team says, no, I think I need a little bit wider, okay, we throw it back into the CAD design, and we start moving it around a little bit. You need a little wider, we can see the changes, we can track the changes in all the parts, and that's how we do it. And then we can take those designs and throw it into your basic FEA type of engineering program. We can do all the strength tests, we can do the flex tests, we can test the bonds between the body parts, we can do all of that stuff because all that, the materials that we're printing from now are well known enough that we can just put it right into the FEA programs, and we end up with the part. Now, just to finish up, just because that's all very mechanical, it's all very cool, but 3D printing can be sexy as well. If you see the part that the arrow is pointing to here, that's a crotch piece. Now, this is a single sled, even smaller building envelope. That part that we're pointing to actually holds the athlete in place. So if you can figure that you're going down a track at 80 miles an hour, pulling 5Gs, you might get the idea that you could bounce around a little bit and end up in the wrong place on the sled. So that's a piece that actually holds you where you're supposed to be, because it's good to be where you're supposed to be. It also holds a whole lot of technology. So there's a lot of technology under there, and it's a sport where you don't have that much to work with. There's like 6 or 7 basic parts in it, in the sled. So you have to maximize the technology that you're putting into each one of those parts. So there's a lot of tech that's being hidden under there as well. but it's the Olympics. So why are we just sitting there making a boring part? We had to span-dangle it up a little bit. It's the Olympics. Go USA. Go team. So we used a polyjet and we printed up a little span-dangling on it to make it look a little more sexy for the games. And these were on every single one of the sleds in the games. So we had a lot of parts. But at the end of the day, parts are still just parts. A basic STL file, pick your material, throw it off, print it up, and that's what you've got, is a basic sled. And so in our world, in luge, it's changing rapidly. We've got lots of new ideas, new technologies coming. We've gone from a sport that, well, we won a few medals in the Olympics back in the late 90s, early 2000s in doubles, and we won a women's medal in Sochi, and we just won a men's medal. If you look at the World Cup rankings and you look at the Olympics, we are actually have come from down low, sort of down in the middle of the pack team. So we are one of the powers in the world. This doubles technology that I just talked about today took us from an average of 12th place in the Olympics to an average of 6th place in the Olympics. So we've cut our margin in half, and going into the next games with the next ideas, I believe we are going to be right on the podium with the doubles program, just like we have with the singles, and we have men, and we have been with the singles in men and women, and I believe that this technology is definitely what's helping us out. So in the end, we're printing parts, and we're going to the Olympics with them, so keep your eyes out. It's really changing in a lot of sports for us. Thank you very much.
All right. Thanks, John, and congratulations on pushing the boundaries for Team USA. Moving from the Winter Games now to Hollywood, I'd like to welcome to the stage Scientific and Engineering Academy Award winner, Brian McLean from LAIKA. Brian?
Thank you. It's very nice to be here. I'm very excited. Whoop, jumped a few slides here. Hi. Let me try that again. It's very nice to be here. Thank you guys very much for having me. My name is Brian McLean. I'm the Director of Rapid Prototyping at LAIKA. LAIKA is a little studio up in Portland, Oregon, who does stop-motion animated films. And I heard Rich ask a little bit earlier how many people had seen Kubo. I heard it was only about 10%. We've done 4 films over the last 10 years, Coraline, Paranorman, The Box Trolls, and Kubo and the Two Strings. So can I get a show of hands of how many people have seen one of these movies? All right. So what you guys don't realize is in your terms and conditions, if you downloaded that little app, you guys all agreed to watch one of the movies within the next 60 days. They're all on Netflix, so you don't have an excuse. It's all free. LAIKA not only does stop-motion movies, but we have a long history in the 3D printing world. And before I get into explaining how we use 3D printers, let me show you a little video that explains a little bit more about LAIKA.
When you walk down the halls of LAIKA and you enter any set of curtains, what you enter into is always going to be a complete surprise, and it's going to be completely different.
It is absolutely true that every new movie that we make gets that bit more ambitious.
We want to make films that push this medium that we love, animation, that push it in new directions.
And we're moving in directions that stop-motion animation doesn't normally go in.
And so every film demands something new, but everyone's up for the challenge.
We've got a brain trust of brilliant creatives here.
We have people who are sculpting puppets, we have people who are making sets, we have people who are animating all day long.
And I think that's what's cool about this place, is it's this tactile wonderland.
No!
To do it practically in camera is something we try to do as much as possible. But at the same time, we bring cutting-edge technology into the process.
Whether it's science or innovation, it's worth a risk sometimes to go out on a limb.
And with each successive film, we all work and grow as artists.
We really wanted to find a way to push facial animation beyond what we'd ever done before.
And the subtlety and a range of emotion.
You get totally transformed into the story and you forget that you're watching a little 12-inch puppet.
It's hands-on, it's tactile, there's a life to it that most other animation forms don't have anymore. We're a group of really talented artists who want to do it the best that we can.
Here at LAIKA, the energy, the atmosphere just really crackles with that creativity.
We don't have to be limited in the stories that we tell. That's what's exciting about the studio.
It feels like we really are just scratching the surface of what this art form can do. And that's incredibly exciting to me.
You're here, Kubo.
So stop motion animation is one of the oldest forms of visual effect. It's been around since the dawn of film itself. Now, one of the ways that you would animate different facial expressions in stop motion is called replacement animation. Replacement animation is the technique that used to be done by hand, where you would hand sculpt hundreds of different facial expressions. As you were animating the puppet, you would put on a facial expression, take a picture, and then replace it with a slightly different facial expression. When you knit those images together, you got the sense of movement. Nightmare Before Christmas is a really good example of replacement animation. This is Jack Skellington, the lead character from that film, and he had about 800 possible facial expressions. Back in 2005, LAIKA had an idea of what if you were to take this age-old technique of replacement animation, infuse it with this emerging 3D printing technology. We started working with Stratasys on one of their early PolyJet machines, and we produced characters for the film Coraline that we 3D printed all of their facial expressions. Now, as you can see here, we had to go in and hand paint each individual facial expression. The results were astounding. The stop motion and film world had never seen anything like this. You suddenly had this character that was emoting in a way that would never have been seen before in the medium. But the problem was we had to hand paint each individual face, and it was very laborious and time-consuming. In all, we produced about 20,000 faces for the film Coraline. So after Coraline, for our next film, The Box Trolls, we wanted to try something different. We knew we had tapped into something with the 3D printers, and we wanted to see if there was a way that we could infuse color into the 3D printed parts. You guys are all probably familiar with this. This is a 3D Systems Z650. And this is what we actually used to produce the faces. The faces were printed out of this powder material, and then we would go through a process of needing to fuse them with super glue.
Awesome!
So the problem with the super glue process was that it was really easy to screw up a part. You could easily rub off a nose or break a lip. So we were using it for the faces, and we were still using the PolyJet technology for all the internal components. So what you see here is a character, Eggs, from a movie, The Box Trolls, and he had about 60 pieces that were designed and engineered custom for his face or custom for his head, and they were all 3D printed out of PolyJet technology. Because of our techniques and because of what we had pioneered, we actually were awarded a scientific and technical Oscar, also known as the Nerd Oscars. And this is not like a normal Oscar where you have the stars and it's a very glamorous red carpet thing. But this Oscar is not tied to an actual movie. This Oscar is tied to a process. So it took many years for the Academy to come out and investigate our process, and they actually wrote a book, a 100-page book on our process that lives somewhere in the Academy vault. And they decided to award us this award, and you have to prove that you are changing the industry for the better. Your technique that you developed is having a lasting impact on the film industry. So that was a huge honor for us, and we're really excited. And ironically, shortly after that huge success, we were getting ready to start on our next movie called Kubo and the Two Strings, and these three characters gave me sleepless nights. These were three characters that don't look like much. Their sides are a little scary. They had traits on their faces that were going to be impossible for us to produce using our old 3D printed technology. So just after we had won this wonderful award, suddenly we had no way of actually producing the characters on the next movie. So I was at a crossroads. I either need to go back to the director and say, hey, you're going to need to change the way the characters look, or we had to find some new way to achieve the director's vision. At the time, the Connex 3 had just come into beta. It was this 3-material printer. You had the ability to produce 3 different colors. So you could put 3 colors in the machine, and you could produce about 45 uniquely blended colors. But you were limited to 3 colors, and you were limited to how you could assign those colors through shell assignment. But we knew that if we were going to make this work, we had to find a way to work with Stratasys and be very creative to come up with a solution. So Stratasys essentially allowed us to bypass the printer, bypass the software, and to slice our own files. So we were doing voxel printing back in 2014. Voxel printing is what I'm going to talk a lot about later today. But essentially what we were doing is we were taking these discrete colors, we were expanding the palettes through lookup tables, and then we were able to do a texture map painting. So what you see here on the screen right is beetle and monkey after they've come off the printer. And it's hard to believe that they're made out of only 3 colors, but their faces here are only out of 3 different distinct colors. We'd animate the faces in the computer, produce literally thousands and thousands of them. For Kubo, we had over 64,000 faces that we produced. And then we would send them to the printer. So this character here, Moonbeast, was our first and the world's first fully 3D printed puppet. And rather than explain it, we have a little brief video that'll run you through it.
The climax of the film centers around an epic battle between Kubo and the dreaded Moonbeast. The Rapid prototyping team had written their own 3D printer software, allowing them for the first time to print highly complex colored plastics. By developing this 3D printing software, the filmmakers could control material and color placement on the voxel level. Over 150 body parts were designed, sculpted, and texture painted in the computer and then 3D color printed out of plastic. Each 3D printed body segment was then backed with gold mylar and assembled around a gooseneck armature, allowing for smooth, sweeping animation and subtle control. The puppet was built at 1/5 scale and animated with multiple camera setups and an elaborate rigging system. The camera team had to create a separate workflow for shooting this character to hold focus and achieve a deep depth of field. They accomplished this by cropping a usable 3K image out of the 5K RAW file, as opposed to resizing the full chip image to the working size of 2K. In order to realize the desired look and work around the 3D printer's limited color gamut, the RP, camera, and VFX departments worked together to come up with the right formula of color 3D printed materials, lighting, and a digital post-process. The puppet was shot on green screen and photographed under 3 different lighting scenarios. 2 white light passes were layered and combined before passing through a multi-step color process. An ultraviolet pass brought out the edge lines on his body, adding a radiating cyan glow. Using Oscar award-winning RP facial animation technology, over 1,417 Moonbeast mouths were printed, taking more than 147 days of round-the-clock printing.
Then I'll just have to rip it out of your head again.
So after the movie Kubo came out, we were really excited by how well it did critically. It was one of the highest ranked movies on Rotten Tomatoes. It went on to be nominated for Best Animated Feature. But what was really amazing is it also went on to be nominated for Best Visual Effect. And this is the first time a film had ever been nominated in both the animated category and the visual effect category. And that had a lot to do with the techniques that we had helped pioneer using 3D printers. So what's next? What is LAIKA working on now? Well, we're on our 5th film. We've actually just wrapped it. It is in post-production, and we're using the J750, which is this multi-material machine from Stratasys. We started working with this in 2015, in early beta, and then in 2016 we got the first 5 off the assembly line. Now, I don't have a lot of imagery to show about the technology because all of the imagery that is for the film is still under wraps. But over there on the table is probably one of the scariest things you guys will ever see. It's a human head that was printed using the J750 with this software combination that I'm talking about. And we also have some puppets over there after the show, and I'll be over there answering some questions. But ultimately, what we're doing with the J750 is very similar to what we did with the Connex 3. We are using the hardware to produce amazing results, but we're using software that we got from somewhere else. And we're using software from a research facility in Germany called Fraunhofer. They developed this software called Cuttlefish, which uses a color profile and slices the models ahead of time. And then LAIKA, we slice them on a render farm. And then LAIKA built our own sort of BMP assembler, which allows us to take these package of slices, and instead of arranging 3D models on a print tray, we're arranging the slices on a print tray. And that allows us to get away from some of that spooling architecture that you get when you're sending a print with a lot of dense data, and suddenly the printer may crash because it can't generate slices fast enough. We're doing the slicing all ahead of time. So, talked a lot about replacement animation, but the rapid prototyping department does a lot more than just facial animation. We do a lot of practical effects. And over the last 10 years, I put together a little video here to show all of the other practical effects that we use 3D printers for.
Get up! No, don't! Look what I did!
Thank you. I have one other slide, or excuse me, one other quick film, and before I show it, I just want to give a little background to this. At the end of, for those of you guys who have seen a LAIKA movie, if you stick around to the end, you'll see these little Easter eggs that we hide at the end of the credits. And this particular one was at the end of Kubo. And what was really cool about it is it's an amazing time-lapse imagery, but when we were going to do it's called a VFX bake-off, when you get selected to be one of the finalists for an Oscar nomination for a visual effects award, you go and you give a big presentation to a bunch of visual effects nerds. And that presentation there's a lot of very strict rules. You can't show things that are not in your theatrical release. You can't show green screen elements. You can't show behind-the-scenes footage. All you can show is just the finished footage, and you have to get up there and sort of explain it, and then you let the imagery speak for yourself. So when we showed this time lapse, the audience members were going nuts. There was all these whispers saying, "LAIKA's cheating. They can't show this. They can't. This is behind the scenes." And then there was sort of this sudden realization that, oh, actually, they can show this. This was part of their movie, and this was in the theaters. So then we had people coming up to us from Star Wars and Avengers movies after the fact and saying, "You guys are brilliant. We're going to now start putting all this behind the scenes in our movies so we can show it in the visual effects bake-offs at the end of the year." So without further ado, here's this little time lapse.
While my guitar gently weeps, look at you all. Still my guitar gently weeps.
Thank you guys very much.
All right. Thank you, Brian, and congratulations to you and your team for breathing new life into one of the oldest forms of entertainment. So while we're happy to celebrate the innovations of today, we're all very hard at work at Stratasys on the innovations of tomorrow, including our H2000 system that we developed in conjunction with our partner Boeing for large prototypes and production parts, and our robotic composite system that we're developing with our partner Siemens for large composite tools and composite production parts. We're also very pleased to announce the development of our new Stratasys metals technology. And to hear more about that and how our customers are further leveraging business innovations with 3D printing, to close us out, please welcome Dr. Phil Reeves from Stratasys to the stage. Phil?
Thanks, Rich. I should say thanks, boss, I guess, but hey, thanks for hanging around for us to come and wrap this up today. I'm going to split this presentation into two parts, and in the middle, we're going to have one of those polling questions just to keep you guys on your feet and keep you awake. First part of this presentation that I really want to focus on is about business innovation. You know, we've heard from the guys at LAIKA and we've heard from the guys at USA Luge all about how they're using 3D printing as a technology to drive forward their tangible products, to drive forward innovation in the physical things that they make. And they're doing that using Stratasys technologies faster. They're doing it with better color, better realism. But you know, there's more to business than just product. The thing that really excites me and interests me about 3D printing and the work I do in our consulting group in Stratasys is actually more about the method and the idea. What goes behind a company adopting this technology? Why do we use it? You know, we don't just use it to innovate new products. There's some great work that was done around 2010 by a company called Doblin. Doblin's now part of Deloitte Monitor. And Doblin did a kind of an innovation canvas across business. And they identified that product development and tangible is just one part of the business landscape. There's actually a whole range of different parts of your business that you can innovate. Whether at one end it's the profit model that you use and the business model, or whether it's your supply chain, or whether it's your product that you innovate, or maybe it's the other end. Maybe it's the way you engage with your customers. Maybe how sticky you get with your customers, the way that you engage them in the whole product development and realization process. There's a lot of different ways that we can innovate our businesses. And interestingly, Deloitte did some further analysis of this, and they showed that companies that think beyond just product innovation, but start to think about process and business innovation, are the companies that grow. The strongest companies on the FTSE and the NASDAQ and the SP 500 are the ones who've gone beyond just product innovation and looked at system innovation, supply chain innovation, process innovation. And this is kind of what excites me, because 3D printing is more than just making a 3D object. It's a technology that allows us to think very openly about the way we configure our supply chain. It allows us to think differently about the way we use raw materials, how we use resources, how we think efficiently about our supply chain and then the products we bring to market. Of course, lots of freedom of design and flexibility with 3D printing. And of course, we know the economics here. We can make low-volume production components far more cost-effectively. But you know, we can embed functionality into products. We can displace manufacturing processes. We can personalize. There's an awful lot of things that we can do with 3D printing. And it's kind of interesting when you map this against Doblin's framework for innovation, because you start to see all these different business reasons why we should be embedding 3D printing into our organization. So interesting, that polling question earlier that said one of the biggest barriers was cost and getting your management on board. Well, actually, maybe the way to get your management on board and to understand the true cost of 3D printing isn't to think just about product development. It's to think about the business benefits, the ways that you can change your profit pools, the way that you can change your organizational structure. That's how you get management to get excited about 3D printing. We've done a lot of mapping over the last 5 or 6 years about where these innovation steps come from. And you know, there's a lot of different benefits that we can have across the supply chain, benefits around efficiencies. You know, if you look at a lot of the great case studies of where 3D printing is being used today, it's being used to drive those efficiencies in supply chains. The much heralded GE jet engine components. Why are we doing it? We're doing it because GE makes more efficient jet engines, reduces fuel consumption. The business benefit is actually in the application of the 3D printed part. So lots and lots of business benefits from 3D printing. I just want to have, as I say, one final polling question before we talk about some new product innovation within Stratasys. So if we could go up to the poll, wherever it will appear. Maybe there is no poll. Here we go. So our poll, we're really interested to understand where you guys truly think you are. I know there's a lot of new people to RAPID here, but are you new to the 3D printing industry? So where are you in this journey to integrate 3D printing into your production? Not necessarily into your prototyping and your product development, but into your production. Is it jigs? Is it fixtures? Is it tooling? Is it end-use parts? Is it in the supply chain? Is it spare parts? Is it reducing inventory? Where is it? So interestingly, 36% of people would say they're fully deployed and operational, but the largest proportion of you here today are new to RAPID. That's an interesting dichotomy. But at least we're all in the right place. So let's move on from the poll. I want to spend the rest of my time talking about product innovation, and something that we're really proud of within Stratasys. Because whenever you innovate a new product, you want to tell the world about it. And this is metal. Now, I joined Stratasys 3 years ago, and not a week goes by when people say, what's Stratasys' metal strategy? What are you doing? Everyone else makes metal machines. And I guess it's not a secret that Stratasys has been involved in metals for a long, long time. We've been looking at metals for many, many years. You know, we acquired Harvest Technologies 3 or 4 years ago and integrated metal service bureau work into our own Stratasys direct manufacturing. We invested in LPW powders to really understand what the metals domain looked like. We've recently spun Vulcan Labs out of Stratasys to focus on powder bed fusion. But internally within Stratasys, there's been a lot of work in the background looking at metals. And I guess the reason that we're saying this now is that we've watched the market, we've understood the dynamics of what's going on. It's a very competitive landscape out there in metals. There's a lot of technology vendors. But there's some common threads that we think we've identified. One is high cost of ownership. Expensive machines that actually have relatively low throughput. Whenever you do the production economics on metal additive parts, you're always faced with this dichotomy of speed and time and price. You've also got a lot of complex pre-processing, support structure generation, orientation, building a part to prove you can build a part. And then you've got post-processing. You've got a lot of support removal, a lot of machining, a lot of powder handling going on. Or you have incompatible metallurgy. Whenever you start mixing organic binders with metal powders and furnaces, you risk the chance of contamination. So on one hand, you've got laser-based systems that are relatively slow, and they're expensive, and they manifest as expensive parts with expensive raw material, or you have powder bed systems which, okay, they may produce more cost-effective parts, but there are issues about metallurgy. So within that landscape, we've been innovating over in our labs in Israel. And our starting point, and what we're launching here and what's on display next door, is aluminium or aluminum. It's a real challenge, aluminum. It's a challenge for powder bed laser systems. You need a lot of energy to process aluminum. It's a relatively low-cost material. So when you put it on a machine and try and laser melt it, you need lots of energy. You have a slow build. So there are some issues. It doesn't work particularly well with other powder bed systems. But if you look at aluminum as a material, it's actually a big marketplace. 75 million tons of aluminum parts a year. Within the transport sectors, consumer goods, machinery, industry sectors that we know and that our customers are already working within. So what we've developed is a technology that uses some of the proprietary knowledge that Stratasys has around jetting. It's been built from the ground up, so it's never been built as a prototyping solution. It's a production aluminum part manufacturing platform. Another, I guess, change of direction is the materials that it uses are industry standard materials, using industry standard economics. This isn't gas atomized, spherically graded metal powder. This is industry standard metal powder used in powder injection molding, metal injection molding around the world. What we've also tried to do is develop something that's an industry standard workflow, something that integrates into existing businesses, into existing supply chains, into existing factories. So that's what we're getting today, high quality aluminum parts. Parts that are really aimed at the automotive, the defense, the aerospace, industrial machinery, white goods manufacture. So think parts that typically you would either make through powder injection molding, metal injection molding, die casting, investment casting, in unit volumes of 10s, 20s, 50s, 100s, 200s. That's where the technology fits. That's the sweet spot. Some other key things here, a bit techy, I'm afraid, but it's worth pointing this out to you. The architecture of the technology that we're announcing today, what you put in is what you get out. The chemical composition of the metals that come out of this process are exactly the same as those that go in. There is no percentage of other organic carbon-based material in there. 99.95% density of material. No evidence of anisotropy in that Z-axis. An industry standard mechanical properties, so 270 MPa as an aluminum material. So very common industry standard figures that you would expect from a powder-based aluminum process. So just to wrap up, cost reduction, our care here and our consideration is not necessarily cost of hardware, but the cost of the components that come off that hardware. And what we found with this technology and the way that we've architectured it for productivity, we get an 80% reduction in aluminum part cost compared to today's laser-based additive technologies. Largely, we achieve that through using a standard traditional metal powder route. The other thing we get is operational simplicity. We've architectured a technology that doesn't think about traditional support structures that you'd see with metals technologies. So we talk about post-processing going from hours down to minutes with this technology. And throughput 9 times faster than lasers on aluminium. And again, I have to stress this, industry standard workflows. We don't want to reinvent the manufacturing process. We want to integrate 3D technologies into existing factories. And a key teaser to leave you with, high density green state parts. That's a real important differentiator here. So with that, I want to finish up and wrap up for Stratasys. I hope the keynote has been of interest and stimulated you with some fantastic work that our customers like LAIKA and US Luge are doing. With that, I'm going to hand over back to Debbie from the SME to wrap things up. Thank you.
Please welcome back Debbie Holton.
Thank you. I'd like to invite all our presenters back to the stage quickly. We have a nice thank you for them. And wasn't that just amazing technology? I can't believe all those animations. And I want to put the animated people on the luge, see what happens. So here, John, that's for you. Thank you. And Brian, that's yours. Thank you so much. And Phil, thank you, Rich. Appreciate it. Thank you very much. Thanks, you guys. Thank you. Thank you very much. And thank you to Stratasys. We have the photographer. He's here. He's here this time. All right. This is perfect. Thanks to all of our presenters today for a powerful kickoff to RAPID 2018, RAPID plus TCT. If this is your first time here, please join us this evening for a first-timers meet and greet reception sponsored by RAPID plus TCT and SABIC. It's taking place right now, hopefully nobody started without you, in room 121A and B. So that's right outside these doors, and people are there to direct you. You would have received a ticket. And so RAPID plus TCT event advisors and members from the Additive Manufacturing Community will be there to meet you and tell you how to get the most out of RAPID plus TCT. Thank you all for attending. We'll see you right back here tomorrow morning at 8:30. Be early. Get a good seat. Take care.